Most people learn Excel formulas by memorizing syntax, but that's not how data analyst works in real life. So in this video, I will show you how real-life Excel formulas answer real HR business questions using an actual HR data set, the kind you see at work or interviews. So we'll clean up the messy HR data, we'll validate some columns, we'll flag the high-risk employees, we'll validate the employee tenure. We'll use Excel formulas to answer questions HR leaders actually care about, like the pay equity, the employee turnover, the productivity, resignation risk, and so on. So this is not about knowing formulas or memorizing formulas. It's about thinking like a data analyst and using Excel formulas to work with it. So if you are new here, welcome to Emmy the Analyst channel. Kindly subscribe to my channel, drop a like, check out my previous videos, and drop a comment. You can also share to your friends, to your colleagues. So this video tutorial is beginner friendly, and we're going to take it a step further into the advanced, and it's also going to be in two parts. It's split into two parts. The part one is focused on data cleaning, data validation, employee risk logic, then answering some high impact HR questions, while in the part two we'll focus more on answering more of the high impact HR business question, all using Excel formulas. So let's get right in. So first of all, before any analysis, a data analyst's first job is to make sure that the data is clean, is reliable, is logically sound. Right now we have our data set here. We have the employee ID, department, gender, year at company, employee satisfaction score, resigned. It's showing that have they resigned, yes or no. There's a true, there's a false. So the false means they are still in the company. Resign means they have left the company. It's the monthly salary in dollars. This is the work hour per week, work project handled, overtime hours, sick day, and all of that, education level. So the first data cleaning I want to do is to use functions like trim, proper, upper, and lower to clean up like my department, gender, job title, education level. So basically, some data could have white spaces, some could just be capital letters, small letters. So I want to standardize it across board. So I want to work first of all on the department. So I'm going to create a new column just after department, before the gender. So I'm going to right click on the column C, right click, and click on insert. So that's what the plate. So I'm going to put department underscore clean just to separate the two. So first of all, I want to trim. Trim removes all spaces from text except single space between words. Right, so any white spaces at the beginning or at the end, trim helps us remove it. Then another thing I want to do for the department, so is to let's do this first. So I've trimmed the IT. I'll just come here, the bottom right, not this cursor, double click. It does for everything to the end. Now looking at scrolling down, control arrow down, we could see that we have about 100,000 data, right? 100,000 data. So So one thing I want to do here again is to let's use upper. Upper converts its text string to all uppercase letter, right? And it keeps it everything across board to be standard. So let's see what we have. Good. You can see that across board now we have all capital letter. You can also do it in lower. What does lower does? Lower keeps everything in small letter. So let's see. So and basically I don't want this. Then we also have another one called proper. Proper, every first letter of every word is uppercase, while the rest is small letter. That's proper. So something like this. Or let's keep it in upper. Let's use upper, as you can see. So double click, have it across board. So what I did now, the implication is that it prevents duplicate departments, right? It ensures accurate reporting by departments, and it improves trust in the dashboard and the reports. So I'm going to do the same thing for the job title. So before I do that, I'm just going to copy the whole of this department and replace it right here. So all I'll do, click on the first, control, hold your control, hold your shift, hold your down, arrow down to highlight everything, copy it, come here, control up, come up, then come here, then right click, paste value, not paste value, right click, paste value. Good. So I've replaced this with this, so I can delete this column. I click on this place and press delete. So department is cleaned. Now job title, I'm going to create another column by direct. So I don't need to actually give it a title, so I can just work. Now basically this table, this data set is a range. It is not a table, right? It is a range. The difference between a range and a table is that a range is a selection of cells, no special format, no structured format. But a table is a structured, formatted range. Okay. So for the job title, I'm just going to trim. I don't need to. Okay, I'll trim and do proper. Let's do it proper. Let's do it proper. Close the bracket. I do the bracket twice. Okay, so I have this. So all across board. So if I have anywhere that has any white space across, to be cleared. So I'll copy this. Since that's highlighted to the bottom, I'll copy all of it, then paste here. Paste as value, right? So I'll delete this column. Now we have the higher date here, and I'm seeing 3056, 3056. Why? Let's dive deep and see. Coming here now, I could see that this date is the 19th of January 2024. This is 18th of April 2024. So they don't have different dates. Looking here, I could see that the format was a custom format. That means you could see now this is a real date, but there was a custom format on it. So what I could do, I could just highlight the whole of the dates. Remember to highlight, Ctrl Shift arrow down. So I'll change to a short date. See, that could work. I could use a long date too, but it will be too long. I don't want that. I'm just gonna go with a short date. Ctrl Z. Go to a short date. So this makes more sense. So coming to the year at company now, we have a date here already. So as analysts, we never blindly trust calculated field. We verify them. That's part of our work. We verify any calculated field. Like here at company now, we could know that it's calculated based on the hire date. So we have to verify it. I want to validate the year at company. This video is being recorded the year 2026, right? So looking at it, I could see that this is 2022. So I should be having 4 years here, right? 4 years. So it tells us a lot that, okay, probably this year that company was calculated 2 years ago, probably 2024. As you can see here now, we have 0. So we have to recalculate it to today's date. So we have a function called DATEDIF. So I'm going to put it in DATEDIF, open the brackets. Now I want to calculate this DATEDIF for the hire date. Compare it to today. There's a function called today. Right, close the brackets. So I'm checking that hire date compared to today. How long in terms of what? Years. So y gives us the year. So I close the brackets. So rather we get 4. Check the formula. DATEDIF. The F2 is the hire date. I'm checking this hire date compared to the today's date. How long is it in the year? Right? So all I have to do is to click. So now crossboard, my answer is correct. So what I will do, I'm just going to leave this year at company like this, so that a month's time when we open the data set, we will see that it's making it to make some changes. Probably this time next year is going to be 5 at the first column. It's going to be 2 at the second column, right? So that's the power formula. So I'm going to leave it like that. The next thing I want to do is the education level. So I'm just going to do a basic cleaning also, just to be double sure. Even if there's no error, but just to be double sure, I'm going to do some basic cleaning. I'm going to use proper also. Proper. This. So I close the brackets. So I double click. Then I'll copy it, Ctrl C, come right here, right click on the first, then paste value, right? So I'll delete this guy. Okay. Now the implication of this is that for the year at company now, the implication is that if we have any incorrect year at company, it could affect benefits for the employee. It could bring about unfairness in evaluating the employee, and system errors also. While the education level too, it's very important that we validate all of that. So basically, that is all we are validating from here. So the next thing I want to do is to categorize our performance. We have a performance score here, and I could see it's basically 1 to 5. Now, one of the fastest way to have a glance of your table, as have an overview of your range. This is not the table right now, it's a range. One of the fastest way is to put on the filter button. Now, how do I put on that? You can come here and click on the filter, right? This arrow pops up. That is one way, but what I will do, I've off it now. So go to your keyboard, press the Ctrl Shift L, it pops it up. To put it off, Ctrl Shift L also, it goes off. So Ctrl Shift L brings it up. Now you must know that to use this, you must have an heading. So now if I check through the performance score, I could see that I have 1, 2, 3, 4, 5. So performance 1, 0, 4, 5. So basically, we have 1 as the poorest, we have 5 as the excellent. You understand? So we now need to categorize our performance. So I'm going to create a new column, insert. So performance, I'm calling performance category, right? Category. So I'm using the ifs function. Ifs. Let's check it out. IFS. Ifs. Now, what does if does? Let's check what it does. I'm going to enter the function. Okay, before I enter, ifs check whether one or more conditions are met and return a value corresponding to the first true condition. Right? So I want to check for several conditions. Ifs check for several logical conditions. So the first question I want to check is that is it greater than 4? So when we make greater than 4, we have 4.1, 4.2, 4.3 to 5. That is excellent. Performance greater than 4 should give us, so I put it in double quotes, excellent performance, right? So comma. What's the logical test? What am I checking again? I'm checking if this performance score also is greater than or equal to 3. I want if it's between 3 and 4, should be good. Right? Should be good. Okay, good, fair, good. So let's have that double quote also. Then if every writing stands true, that is, I'm going to use the function called true. So I will use, sorry, I'm not done with that. I'm gonna use it as need improvement. I can call it need improvement. That means it's not really good. So let's drag down first. Let's see. So we could see that 2 needs improvement, 3 is good. So 4 will be good. No, 4 will be good, yes, but 5 will be excellent. So let's check out 4. 4 is good, 5 is excellent. So if you have any one like 4.1, let's check it out. 4.1, which is excellent, right? So the formula is helping us navigate that. But we have just 4. So we're going to double click to do for others. So the category lets us know. Looking at it now, we have excellent, we have good, we have this improvements. So we're able to categorize performance. Now I'm going to do the same thing for the employee satisfaction. Checking through it, I have the lowest as 1. Now this has some decimals. I have the highest as 5 also. Right? So for this, I just want to have low satisfaction satisfied, right? So I'm going to create a new column, employee sat category, right? So call it like this, employee satisfaction category. Now for this, I'm going to use the if function. The if function. I'm going to say if, equal to. Remember, before you work on your Excel and any formula, you must start with the equal to. That is the most important thing you need to know for formulas. Start with equal to. So equal to if. So if checks just one logical test. Right? One logical test. So I'm checking for if the employee satisfaction score is less than 3. So I'll say it's low satisfaction. else is satisfied, right? So let's just double click. So consider was satisfied in some. So we have several low satisfaction. So we're able to categorize our employee satisfaction category. So the last thing I want to do for this data preparation is to identify resignation risk. Now, the way I'm looking at it is more like, okay, I want to check the sick days and the performance, the employee satisfaction score for that employee. Okay, if the employee, I'm going to say that, okay, if the employee satisfaction score is less than 3, right? That is low satisfaction, right? And the sick days is more than 10. That is a high risk employee. That means it doesn't perform very well, and the sick days it has is very high, more than 10. That's a high risk employee. So we're going to use the if, the and function. So we'll do this right here. Do it right here. So I'm going to call it resignation risk. Let's call it resignation risk, right? So I'm going to use, first of all, the if. I'm checking if. Now I'm checking 2 conditions. If the employee satisfaction score is less than 3 and the sick days is greater than 10. So I'm going to use the and function. So that the and lets us know that both criteria has to be met before this thing is rendered as true. Both criteria has to be met. If I was using the or, either of the criteria should be met before recognizing it as true. So I'm checking the and now. The first logic is I'm checking the score. Is it less than 3? It's less than 3. Then I'm checking the sick days. Is it greater than 10? Right? So I'll close the and. I'm checking these 2 now. So let's give some spacing. Right? So if this is correct, I want it to be high risk. Else, just a low risk. So produce a low risk client and employee. We could see high risk employees. Let's check it out. He has a sick day of 14 and he has a very low satisfaction score. So we need to pay attention to this employee, this high risk employee. Look at this also, very low employee satisfaction score and a 12 days sick days. So looking at this also, 1 day is a low risk, it's a high risk, right? So let's look at some that would have a high sick days but good satisfaction score, and something like this. Now it has a 13, which is more than 10, but because this is satisfied, it's a low risk, right? So this answers some questions to check out some employees, help the HRO to actually answer questions relating to the resignation risk for each employee. So from here now we can actually ascertain the percentage of high risk employees based on resignation and percentage of low risk employees based on resignation, and it helps HRO to intervene early to reduce turnover costs and support retention strategy. Probably that staff needs to be paid attention to, that it doesn't leave if it's needed in the company. And it also helps HR to focus on the right employee, not just everyone. So at this point now, our data is clean and enriched with logic, real logic that answer business questions. So now we are ready to answer some business questions, and we'll start answering some questions in this part that will continue in the part 2. Now let me take you to the questions I'm going to look at. So these are questions that HRO asks. The HRO leaders, they ask these questions, and these are questions that actually matter, right? So we're going to move into solving these questions one after the other. Okay. Now remember to scroll on your Excel. We are scrolling left to right. Hold your Control and Shift down. Scroll the mouse. Scroll back. Scroll it, so you'll be able to scroll left and right. Up and down is just without pressing the keyboard. Okay. So one of the first questions HRO asks is whether the pay is consistent across roles and departments. So I'm going to be solving my question over here. Let's solve my questions over here. So the first question is, let's bring it out. This average salary, the job title, and department. So first of all, I want to get out the job titles. And there's a function called unique function. What does unique function do? Let's check it out. It returns the unique value from a range or array. So I want to get the distinct job titles. So I will enter the unique function. Then I'm going to, let's start with the job titles, right? So I'm going to highlight the first, Control Shift down. So let's see what we have. So this gives us all our job titles that we have, right? This is all our job titles across the whole data set: specialist, developer, analyst, manager, technician, engineer, consultant. So I want to calculate the average salary for each of the job titles. For each of these job titles. So how do we go about that? Now there are two ways to go about this. I'm just going to show you a more stiffer approach. I call it the stiffer approach because it's not really flexible. It's using filter. Okay, now let's check out something. If I could do filter, so what this does is that I want to get out all the salaries. This salary column where the job title is specialist. So let's check it out. So these are all the salaries where the job titles are salaries. So what I can now do again is to now calculate the average. Good. So I got the average of all the salaries where the job title is specialist. So this works. This is cool, but I'll show you another approach using the average if. Now, if we for us to dragging down won't work. It don't work. You know why? I want to show you why. It's already giving us error. Let's delete that. Now, before I can drag down, I need to lock all of this. Just with the F4, we'll lock it. but I wouldn't lock the AA4, which is this, because I want to go down when I'm scrolling down. So scrolling down now, you can see the average salary. Just to put the thousand separator, I can put my dollar sign and make it low decimal place, right? So this is the average salary across board. So this is an approach. The second approach we could use for this, I'm going to show you for the departments. So let's get departments done. Let me show you using the departments. So department, I want to get unique departments. So I'm just going to highlight. So I have these departments: IT, finance, customer support, and all of that. So using the average if, it's the same approach. Average if finds the average for the cells specified by given condition or criteria. So I want to find the average if the range. Now we have three values to put in here: the range, the criteria, and the average range. The range is the range where this department is coming from. The criteria is this particular cell, while the average range is the salary. So you have to understand this. So Excel is very smart. It helps us to understand it. Like now, if you open a formula, it tells you what is needed for that formula. So right now we need the range. What's the range? So rather than me highlighting just where's the departments, just year to year to the end, I could just do like this, right? Apart doing that, I have my B to B. So apart doing that, I put my comma. The criteria is this, right? Comma. The average range is my monthly salary. Where is it? This. So let's close our brackets. So this helps us calculate the average range across. Now to just double check, let's use the average range for this. So average if so we're going to do it quickly. The job title, this is a job title, right? The criteria is this, right? And the average range is monthly salary. So close. So you will see that we have the same value. Right, so the comma with so you can see we have the same value. So either of the formulas work, but this is more cleaner, more sustainable, and more excellent. So now we've been able to get the average salary per job, title per department. So we'll see. So let's do for this also. We have a greater comma. So we could look out for the highest. Basically, the highest here is engineering, which is 6417, right? Right, the highest here is engineers also. So the next is managers. Okay, so the next question we're looking at is total resignation by gender. So let's copy that and tackle that also. Total resignation by gender. Now looking at our gender, I think let's check our drop down to be sure. Okay, let's get unique gender. That we could look for the total resignation for each of the gender. Unique gender. So I'm just going to do like this. So doing like this now is going to give me this gender. So I'm going to do this rather. So let's see. Wow, we will see some error. Okay, we didn't clean up the gender column. Okay, we'll do that right now. So all we have to do is to create a new column. So there are different ways of doing this actually. I may not need a new column. Let's do that. So since I know that I have MF, so all I can just do is right click, use find and replace. So Control F opens the find and replace pane. So go to replace. So anywhere I see F, replace it with female. Now I have to be careful with this also. Options. It asks, I have to check this box. It has to match the entire cell content. If I don't do this, for the female, it will become F female. So it's going to give us an error. But I have to say match entire cell content. What does this mean? It means that the entire cell has to be F alone, not F and something. So I say replace all replacements. So M should be male. Replace all 9 replacements. Okay, so close. So let's check out. Good. See, automatically cleans this up for us. So that was one of the fastest way to clean up our gender column. So I want to calculate total resignation for the gender. So for this question now, the HRO wants to monitor whether certain groups are leaving more than others. Want to know those are resigned. Male, how many male have resigned, how many females have resigned, how many others have resigned. So we get to know who is leaving a company more, who has the highest turnover exit rates, right? So and it will help in ensuring inclusive retention strategy. And it's important for compliance and employer branding. We'll use a formula called count if. Using the count if formula here right now. So equal to count ifs, because the count ifs, not count if. Count if counts the number of cells within a range that meet a given condition. This is just a condition. For me, I want to check for 2 conditions. I want to check if the gender is a male and if the person has resigned. So that's 2 conditions. Checking together. So I'm using the ifs, count ifs. So the criteria 1. Criteria 1 is I'm looking for has he resigned, which is this. What's the criteria? True. That means it has resigned. Then criteria 2, is he a gender? That's the gender. This. Then I want it to, the criteria is this, right? So close the brackets. Okay, it's giving us 0 because let's see. Yeah, we're going to use this, not this. So I want to just drag this here. Good. Okay, so we'll see that we have 4,807 males that has resigned. Dragging it down. Okay. So basically, we'll see that the females are resigning more, right? So that the females are resigning more. Because we're able to count the number. So this tells us actually the total number that resigned. So we'll see that we have 10 people that has actually resigned, and this is the proportion sharing across the gender, right? So this could be put in a chart to show total resignation by gender, right? So we're done with this. So we just put the comma separator, and so we have 4,007 male resigned. So the next question we're looking at is, let's check our next question. Total overtime hour per department. So total overtime hour per department. So basically, I'm just going to do the same thing. So I would let's carry that question over here. So this is average. Let's give it a heading. Average salary. Total overtime hour, right? So for this same department, so instead of me doing it here again, I could just use right here. So for this now, the total overtime, I'm using the sum ifs. Why? Because I'm checking for two criteria. Checking for the department has to be this, and I'm going to sum a range. Now let's check the sum ifs. So the sum range, we're summing the overtime hour. Where is it? It is it. Overtime hour, comma, the criteria. The criteria I'm checking for is department, which is this, comma. So I'm checking for this. Let's see. So we have this total overtime hour for this department. So I drag down, I get to see the total overtime hour across board. So for IT, you will see they have over 163,000 hours. So the highest right here is the IT. They have a longer overtime hour compared to others. The lowest I can see here is HR, which is quite interesting. Okay, so we will see that we are answering some questions already, some real business question. So for this now, overtime often looks productive, but it can hide deeper problems, right? It could help us to review the workload imbalance. It could identify burnout risk. It could help staffing decisions. So I could also calculate, let's just bring sales to sales here. I can also calculate overtime, total overtime hours here. So this is the average salary. So let's calculate overtime hour for the job titles, right? I think that would be nice. Okay, so just the same principle, the sum ifs. So the sum range I want to work on is overtime hours. So I'm checking for the job titles to match this job title. So we'll see that so who is the highest? We have specialists as the highest. They have the highest overtime hours so far. Then we have engineers as the lowest, right? So now the next question is departments with the highest employee turnover rates. Okay, because of space, I'm going to bring it down here. Yes, let's continue this way. So I'm just going to do the same unique to draft out my departments. So let's see what it gives us. Okay. Now that's the issue with highlighting the whole column. So I'm just going to do column 1. I think it's 100,000. Good. So column 2 actually. Good. So department IT. So we have our department here again. So I want to get out the turnover rates for each of these departments. Now, high turnover is one of the most expensive HR problems. When the employee keep leaving, and they get to have to rehire new staffs all the time. So it's actually a problem for HR, and it indicates leadership issues. So why are people leaving? So it has to raise more questions. Why are people leaving? Is there a workload issue? Is there a leadership issue? So it also drives targeted intervention. Okay, people are leaving this department. Let's have a targeted intervention towards that department, right? And it's to help to reduce hiring and training costs. Because if you have a staff you already hired, you trained for the work, probably after some months they exit the company, you need to rehire another staff and train them. So that's cost incurred for the company. So and that's a very strong HR problem. So the approach to answer this question is to first of all calculate total employee per department. How many employees in the IT department? So then calculate how many employees has resigned in the IT department. So we'll do the total resigned employee divided by the total employee for each department, right? So and that gives us the rates. So we're going to calculate that now. So I'll do it all in the same place. So first of all, let's calculate total employee, right? Total employee for each department. So we're going to do count. The count if, because I'm having a criteria. Counting if counting for departments. Then comma this. Let's see. So this tells us we have 11,131 staffs. So everything has to add up to 100,000. So this is the number of employees we have, right? So now right here also, I'm going to calculate the total employees that resigned. I think we already did that here. So the idea, so it's count ifs, right? So I'm counting ifs. First of all, I'm checking for two criteria. Therefore, departments, it has to be the IT, right? The second criteria range is resigned, which is this. It has to be true, right? So then this divided by, so let's put it in a rate. Let's see. Good. Percentage. So let's put decimal place. So I should drag down. I could see the turnover rate immediately. We just basically calculating, first of all, this calculates the number of employees that has resigned. Now I've highlighted that formula. If I pick F9. F9 helps us to calculate the formula. So we see that 1064 employees actually resigned from IT. Now I'm going to press escape to come out. Let's come to finance. I should highlight this and please click on an F9. You see 1180. So what does F9 help us do? It helps us to calculate any highlighted cell, right? So this is turnover rate. So you could see that the highest turnover rate here is the finance. We have the highest turnover rate. Then you could see that the lowest turnover rate is the IT. So you start asking questions. Why? What is making the IT employees staying? That is, and the finance employee going. Questions will be raised and dive deep. We dive deep to check out what's happening. Is it the pay? Is it the workload? Is it the leadership? So these issues have to be resolved to curb the issue. So now we've done the turnover rates. So let's have the heading turnover rates. So we also have that for the job title. I think you can do that yourself, considering how we got this done. So the next question is, what percentage of employees work remotely frequently? So we're looking at percentage of employees that work remotely. So if you look at our remote work frequency. So we have some zeros. So anyone that is, so this is a percentage. This is 100% remote, 50% remote, probably a hybrid, 75%, 25%. So all of these are remote. All of these are remote, but 0 is not remote. So we're basically looking at how many of the zeros we have, and how many that are not zeros. So what percentage of employees work remotely frequently, or say work remotely. To calculate this, you have to first of all calculate the total number of employees, which you know is 100,000. Then calculate employees that work remotely. That means any employee that has the remote frequency greater than 0, right? So I'll use my count if. So equal to count if. For count if, I'm counting if for, I'm counting, where is it, the remote frequency, right? The criteria is, it has to be greater than 0, right? That's criteria greater than 0. So then we divide it by total employee, right? So just do the count A. Count A counts for text. So we just use this. So let's see what we have there. So we have basically over 80% working remotely. You see, over 80% of the staffs work remotely. Over 80% of staff work remotely, while the remaining 20% come to the office all the time. So then another thing we look at is the average frequency average frequency of remote workers. So that will just be simply average of the remote work frequency. So basically we have 50%, so 50. So with this now we'll go to inform our remote work policy to understand the percentage of our employees that are working remotely, and to impact the office space and infrastructure, to also affect employee satisfaction and retention. So the next question we're looking at, let's check it out. Which departments are understaffed relative to workload? Wow, let's answer that. Let's put the question right here. So I'm going to bold it. Which departments are understaffed relative to workload? Now, the workload matters more than headcounts. Workload matters more than headcounts, and the implication of this is that we will be able to identify teams that are at risk of burnout. We want to support hiring justification. Okay, why we need to hire more people in that department? Probably because the workload is very high. Then we'll be able to improve productivity planning for each department and each employee. So to calculate the workload, department workload, is to calculate the total project by team size. Total projects by team size. So let's add a new column. So there are two approaches to this. So we have projects handled, 32 projects, and this is the team size 14, right? So let's add a new column here. So if we say projects divided by team size, this gives us the workload across the board. When we have a very high value, that means the workload risk, and which will most likely lead to a burnout, and at the end, resignation. Let's look at this high value here now, 8.25. Let's check it out. Now they are handling 33 projects, which is quite high, but just 4 people handling it. You can see that is a red flag compared to this person handling 32 projects and the team size is 14. You will see that you will see now the performance needs improvement, probably because the workload is much and the employee is not satisfied, probably because the workload is much. That's why the workload is very important to find out. So we'll dive deep into all of this. So from here now, you could see some very high values like this also. Why is one person handling 46 projects? That is high. That is actually very high, right? That's actually very high. So we could see some very high outliers that raises questions. So I'm going to call this workload. Then I'll give you a 2 decimal place. Good. So it will help us to identify staff that have very high workload. So we could also do this for a department, a job title. So I will leave that for you to tackle. You just do this right here. So you remember you could use the average if the average of the project handled, the average of the team size, or use the sum of the project handled divided by the sum of the team size to give you the average workload for each department. So you're using sum if function. Let's actually answer the question. So I'll bring this question down here, and using this, let's do sum if. I'm summing for this department. The criteria is this, right? Then the sum range is project handled, right? So this is the first. So we'll see the number of project handled per department. Okay, so still on this, I'm going to divide it by sum if this. I'm working with this department, the criteria department, and my sum range is my team size. So close the brackets. So I have this, I should make it 2 decimal places. So dragging down, I could see the highest is the IT or the sales. The sales has the highest on the staff relative to workload. So we'll see that the sales will need more staffs, right? Compared, and the list here is the legal team, legal department. So I refuse to do that for the job title, right? So, and that's where we'll pause for part 1. We didn't just learn Excel formulas. We used Excel to clean the HR dataset. We validated employee tenure, flagged high-risk employees, and I even identified which departments may be understaffed based on workload. So that is real analytics work. But we're just getting started. In part 2, we'll go in deeper. We'll analyze pay equity, promotion speed, satisfaction impacts on paid high performers, and the ultimate question HR cares about: who is most likely to resign? So trust me, you don't want to miss part 2. So stay tuned, subscribe to the channel, and stay alert for part 2. Thank you for watching.